This video is designed to demonstrate how to use Stata 14 to conduct a confirmatory factor analysis. For this example, we will use data from the classic Holzinger and Swineford research study that collected data on 26 psychological tests from 7th and 8th grade children. The model that we're going to test is this model here to determine if we can fit a spatial and a verbal construct to three visual spatial subtests or tasks that measure how well students are able to use their hands-on kinds of skills to learn, hands-on visual spatial skills. And then we'll also test to see if these three verbal subtests will then work together to measure the verbal ability construct. The data currently that I have is in spss, and in order to use Stata, we have to save the spss data file as a Stata data file. So any of your statistical programs that are that hold your data will need to be converted in some manner to a Stata data file. It's very easy in spss. We can just go to Save As, and then you can see I've already saved it once, but I'll go ahead and save it again, and I can scroll down to version 14 of Stata, and then I can rename the data file, and I'll save that. So now that I have the data file saved, I can go ahead and close spss down, and then I'm going to open up my folder that I have my Stata data in, and you can see it saved this Holzinger and Swineford data with a .dta suffix, and that's, or extension, and that's the Stata, how Stata labels its files. So one of the things we can do is I could double click on this and open Stata, or I can go down here and open the program. And then what I'm going to do is go to File, Open, and I'm going to open that Stata data file that we just saved from spss. Now you notice, you'll notice that what Stata does not do is it does not automatically open the data into a spreadsheet like spss does. And so if you want to view that data, you'll have to go to the data editor and then go to Browse. And then you can see what the data set looks like. So we're going to close that out, and then we're going to begin our process of our confirmatory factor analysis. So we'll go to Statistics, and we'll go to SEM, Structural Equation Modeling, and then Model Building and Estimation. And what you notice here is we get this what's called a graphical user interface, and so this will allow us to draw our model. And what we're going to do is we'll look at that model again, and I'm just going to put it over here so we can kind of use it as a guide. And so to form our first measurement construct, we'll click on this little icon to add the measurement component, and then we'll just click right about there. And so we're going to name this spatial. And then what we're going to do is add these three subtests. And so we'll come down here and we'll add those measurement variables: visual perceptual, cubes, and losange. Losange, by the way, is a paper folding activity. And we can put our measurement variables to the left of our construct, to the right, up, or down. And in this case, I'm going to keep it to the left. So I'm going to go OK. And you can see how it's formed that graphic. Now if I want to manipulate this at all, I've got to click on the arrow key, and then I can pull that down so we can see it. So now I'm going to go ahead and form the verbal construct, and I'm going to go to my measurement component again, and then I'm going to call this verbal, and then I'll add my subtests. I'm going to add paragraph completion, sentence reading, and word meaning. And then I'm going to go OK. I want to keep my measurement variables, my indicator variables to the left again, and go OK. And again, if I want to align these a little better, I can click on the arrow up above and do that. The other thing we need to do is, you'll notice this has a covariance, or a correlation indicator between spatial and verbal. And so we click on this double-sided arrow to add that covariance. And so now we have our model formed. The other thing I wanted to demonstrate is, if you want to, if you have a more complex model and want to make your drawing canvas larger, you can do it using this procedure. You can make it wider and you can make it longer if you like. Now, to estimate this model based on the data that we have in Stata, we go to Estimate, and we have some different choices, but we typically use maximum likelihood. And then for reporting, what I like to do is get the standardized coefficients and values. And so then I'm gonna close this picture down, and then I'm gonna go OK. And so automatically what Stata does is it outputs your estimates. Okay? And you'll also notice that if we toggle back to the window, those estimates are also represented graphically. Now, you can save this diagram, so you can go Save As, and we can label it and so you can save it in your folder. And what it does is then it saves it as a, let's see, where did it put it? It saves it as a STSEM file. And if you click on that and open it again, it'll maintain those same estimates for you. And so if we go back to the output page, the results, one of the things we want to be able to look at in terms of model fit are the goodness of fit statistics. So we can go up to statistics, we can go back to SEM, and then goodness of fit and overall. And in this case, we can see the goodness of fit is highlighted, and you can get the chi-square tests, you can get single goodness of fit indices, but I typically click all. And then when I run this, you can see that we get the chi-square statistics, and what most people are interested in is the root mean square error of approximation. And you can see for this particular analysis is 0.082, which is a marginal fit, and we can go back and respecify the model to improve that fit, but that would be for another time in doing that analysis.